Okay, welcome back from the break. As we move beyond SNMP and CLI into the world of machine-to-machine communication, we will have more and more networking protocols to choose from. Roque Gagliano is going to give us a little bit of an overview, talk a little bit about the pros and cons with the different options at hand. So welcome up on stage, Roque.
I know we're getting to the end. We're all tired, but I think this is an important topic. And there's two reasons why I choose this topic. One of them is to help you through this dilemma. There is a lot of options. Options are good, but sometimes it's hard to know which are the right questions to ask. So I wanted to give you some clues. And the second part is I think there's a lot of very nice technology that has been developed by the team. And I wanted to make sure that you are aware of it and particularly how NSO can help you. And the main developers are here. I work a lot with Jonas, that's there. So make sure you talk to him if you want to know more about a lot of the great technology we're bringing here. So you see here, I'm going to be talking about NetConf, RESTCONF, gNMI, but also, these are about basically the piping, so the protocols, but also about data models. I gave a standardization data models talk a couple of years ago, so I'm going to also be discussing a little bit what is a little bit of the experience on the challenges or the questions again that customers have been facing. But I'm trying to help you with that, correct? Trying to find what are the right questions, and of course this presentation will not age well because things are moving extremely fast. So one of the key things is if you are in this presentation, you are in the right path, because if you ask yourself which one I should choose, it means that you want to, we are leaving that CLI world, you're moving into APIs. So it's hard to tell you that any of the choices would be a bad choice. In general, you're going to make the best choice and that's going to be the best for you, correct? So, and there's a lot of great reasons to move into this API world. And we had great presentation today. We saw the Orange France team talking about performance improvement, correct, when you move away from CLI. And we had just Christian talking about reconciliation, partial sync from, and a lot of features on your day-to-day basis that you use that are going to be improved when you move, correct? So it's not just about in protocol in itself. There's real day-to-day improvement that you're going to be doing, and you're going to take all the powers of the tools now that you're going to use APIs. Now, as we said, you got options. So you take a device from different vendors, and I'm not going to talk about specific vendors today or and specific OSs in some of the vendors, because the reality in some of the vendors, like Cisco, may be different across OSs, is that in general, you're going to see that there are options. Typically, there may be more than one option in a given OS. So the first thing to be clear, all of them, NetConf, RESTCONF, and gNMI, they're all based in YANG, correct? And that's a great asset. And we're going to see that. I'm going to do a demo at the end that I'm going to show you how we can leverage that, which is extremely important. Now, they are all based in YANG, but they're not exactly the same. And that means that you need to go and ask yourself a couple of questions. And the first one is what options are available. So when you look at your install base, your vendors, it doesn't mean all of them are supporting all the technologies. One of the key things to understand is that each one of these three, they typically have, a sweet spot or a market that they are focusing. So one of the key things is RESTCONF. We're going to see RESTCONF today mainly not on the devices. I have one example is iOS XE does support RESTCONF. Sonic also support RESTCONF. But in general, what we see is more and more RESTCONF, more of a Node-ban API to a controller like NSO, CNC. We have RESTCONF Node-ban. We see that also in optical controllers or microwave controllers, etc. Now, when you see gNXI, you see I call it gNXI. I'm not saying gNMI. And the reason is because in reality is a set of gRPCs. So a set, if you want, of protocols that together make this suite. And this suite was originally intended, originally developed for the hyperscalers, for that specific market. And it didn't come out of the typical standardization bodies like the ETF. It came out of more of an open source software, fast software development environment. But that's important because it was also developed with the processes and the way of operation of those particular entities in mind. So a lot of time that when you talk about gNXI, people tell you it's beautiful. You may find the comment that it's beautiful because it's very simple, but several of those simplifications are thought for specific operational environments that may not tied what you need. You actually need a lot of that, a lot of those other capabilities because you don't work in the same environment and it was originally thought. Now, NetConf on the other side, it's probably the more widely available across all the installed base that you'll find. You saw already the presentation from Orange. But what's very interesting is that NetConf also has a lot of more history on the interop environment, and we definitely is a great choice to have. Now, as I said, depending on the vendor, what markets they're targeting, they're trying to develop the protocols that better suit them, and you need to understand a little bit what options are available in terms, for example, of configuration and telemetry, for example, of reading. I'm going to talk today, from now on, to focus more on configuration. And the reason is, for telemetry right now, when you look at the options available, typically it's going to be gNMI or gNXI, because there's very few implementation of young push, although some of our customers, there's kind of like a renewed interest on making young push happen. And the reality, it has to do with the gNXI protocols use an encoding that is very efficient on the wire, and the use of SSH is not. We'll see that later. So that is today what is not available, correct? So that's what I said. First question, really need to deep dive in your use case, the versions of the vendors you have, and understand what is available. Now, that homework needs to go a step further. If you got more than one option available, there's many different ways to compare them. And, I'm not trying to be exhaustive, just putting some data for you to understand, that they are not exactly equal. But what's clear is that you need to, to kind of like point out what is very important for you. And that has to do with what you want to achieve in automation. We had these 5 levels of automation from Jan and the team. And if, for example, getting network-wide transaction is a very important feature for you, that can only be supported by NetConf, correct? Now, it's true that the long-term plan from the gNXI community is not just based on configuration telemetry. It's a number of network protocols. Now they want to, the idea is to replace them by gRPC-based infra. So in the MPLS World Congress a couple of weeks ago, there was a talk to replace, for example, the PCEP protocol by another gRPC on another piece of the suite. So that's very important. Now, the one thing that you'll hear a lot, which is particularly true for telemetry, is that, of course, NetConf being XML-based, you're going to see that it's more chatty, while the gNXI and RESTCONF based on JSON, but particularly in gNXI based on JSON RPC, it can be very efficient in the use of the communication. That, when you are doing configuration as we are doing, typically that's, unless you do extremely large configuration, that's typically not a problem that you're facing. We also need to understand that from a young, we just said that all of these are young-based, but they're not exactly equal. As NetConf and RESTCONF were developed by the ATF, they do support every young statement. Now, in the case of gNXI, there was a specific, let's say, intent not to support things like RPC, actions, and notifications. So many of us using NetConf, you know there's a lot of RPCs available where you can clear basically everything from an OSPF topology to, to restart a router, etc. So what the gNXI community is doing is defining specific proto, so specific gRPCs for specific functions. So basically what ends up is that you may have in a given router 10 or 20 gRPCs, but you may not have the hundreds of thousands of RPCs that you got in NetConf. So even though the YAML model says RPC or action, there's no way to call that in the gNXI stack. There's something different, and actually typically it's not yet as complete. And that's something different called gNOI. So you may hear that, and gNOI is part of the gNXI library. Now, the other part that is that we hear a lot from customers has to do with authorization. In this move from CLI to API, typically customers were used to use TACACS-based authorization, where every single CLI command was then authorized in the TACACS server. This is changing for NetConf and RESTCONF. There's NACM that allows you to actually perform this sort of authorization policies, but inside the router. Now, when you go to gNXI, actually authorization was not part of the original development. Now, when they have something called GNSI, again, there's a lot of those proto buffer, but I just wanted to raise that that's an important thing for you to check if the authorization mechanism is compatible with what you need, because this is all based on certificates, and we hear sometimes for customer that all of this certificate logic is not part of your operational environment, and it takes a little bit of time to get up to date. So all in all, this list, to be honest, can be very, very fast. But I wanted to mention some example here of one capability that is a very well-known NetConf capability that's called commit confirm. We support that in NSO for a long time, but that was not available in gNMI, in the gNXI family. What happened in recent months was that the community requested that one to be added. So you see how something that is great, very simple, because we remove a lot of these capabilities. But now, of course, to address use cases and particularly operational environment like brownfield that are not so simple, that these capabilities had to come back. And I think we will see that more and more happening. So more and more capabilities that are only available in NetConf moving also into gNXI. Now, so as I said, there is a little bit of work to understand, we talk with a lot of customers that they have an overall decision that are going to follow that, for example, what's tip must, which basically already define NetConf as the configuration protocol. And there's some other customer that says, I really want to go and adopt the WebPlay or the hyperscaler protocols. And those, it could be that the part of the homework we need to do is to really check what are your strategies going. But reality sometimes is it's tough. So just make sure that that check that back with the devices that you have, the vendors that you have, and the version that you have, because just clicking the box and they tell you yes, I support it, it doesn't mean that it has the capabilities that adapt to your operational environment. Now the other thing is, as I said, all of these protocols transport. It's gonna transport certain payloads, and those payloads requires given schema, and we're gonna use YAML models for that. So that's great. So all of them use YAML. This is great, and it's gonna be part of the demo. I'm gonna use this later on. So I'm gonna show you that if you got NSO, it doesn't really matter, because you can actually go and commit with the same template a gNMI and and a NetConf device. So from a service development perspective, it's the same template, so you don't care. So that's extremely, extremely powerful, and that's because we have, both of them are supporting YANG, and most of the vendors support the same YANG models on whatever transport you have. So they're building infrastructure that selecting the transport protocol is not fully transparent. As I said, not all the capabilities are in all the protocols, but it's actually pretty transparent for you. Now, the other thing is, which are these data models? And as we discussed during the previous presentation, you got the native data models, and now we have standardization data models too. And standardization data models are getting momentum, which is great. We see a lot of vendors pushing for standard data model. And the great thing is that they should work in every protocol. So when you look at OpenConfig, yes, OpenConfig, they are developing the gNMI standard, so the gNMI implementation, but OpenConfig data models also work on top of NetConf. So that's one of the key things I wanted to make sure that you're aware. Now, what is the end goal to use these standardization data models? Is to have one data model, one service template that will work across all the different vendors, okay? So one template in your service. Now, when we think about that, and we look at the reality of where we are, it means that you, as a developer, you need to start looking at something called coverage. Now, we were in the CLI world, and in CLI, you basically could do anything you can do in a router. Now, from everything you can do in a router in CLI, typically the goal from all the vendors is to coverage everything the CLI support with the native data model. So that's pretty much a goal every vendor is trying to achieve. A lot of them has been, achieved already. Some of them are not there yet, but probably will be there very, very soon. So I think we kind of like a good degree of confidence. You can say that when you move to YANG-based APIs, that your vendor should support every single configuration in the native data model. That's not true for the standardization data model, because it's clear that there are vendor-specific configuration that will not be available in the standard configuration. And we had to think that each of these standard configuration is pretty much like a different API. So the native data model is like one API, OpenConfig is another API, and IETF is another API. So when we talk about coverage, there's two types of coverage. One is at the device level, so making sure that anything you want to do in the device is covered by the YANG model you choose. But the other one is at your use case level. Can you deploy your use case using the standard data model? Okay, for that device, for that vendor in that place. So that's a homework you need to do also. Now, you can do that with the reality that you have today, but also you need to understand a little bit what's going to happen tomorrow when a new use case comes, and you need to also check the coverage, maybe in a version of your OS that it's a pretty older than where the standardization is. So I'm saying this because you need to understand for the future what kind of environment you run. Are you an innovative company that it's always running the latest and greatest feature of every vendor put in place? Or this is something that where there's not a lot of innovation, it's just a simple use case, could be an optical transponder, it's just a switch that I'm programming a VLAN, I don't care, there's not going to be any innovation on this use case, on this environment. Because if you are greatest and latest feature, the chances that your use cases will be covered by standard data model are pretty slow, okay? So that's extremely important when you think about coverage. Not for today, but also you need to think that you don't want to move from one to the other one very fast. Now, when we do the same thing, but across multiple vendors, you also have another trick, is that currently in the standardization data models, there can be deviation between vendors. So even though you have coverage, you may still have some if statements in your templates. And the reason is, some of the, even in a given data model from OpenConfig, there's 3 ways to do a shutdown of an interface. So some vendor may support one way, another vendor another one. So you still need to accept that goal to have a single template across vendors is going to take time. So automation of testing is imperative. And every customer that is running OpenConfig or these sort of standard data models, it's running an automation of testing process. Some of them are even giving the test case to the vendors to make sure that the vendors are testing the OpenConfig use cases before they deliver any hardware or before they're even allowed to sell the hardware to the customers. And the next thing you might think is, okay, I don't have full coverage. Let's go with the mixed model. So mixed model means I'm going to actually have 80% of my template in OpenConfig, 20% on native data model. That's fine. However, there's a problem here. Remember that we think about the source of truth, correct? You want to have a source of truth for the config, and you want to be source of truth, particularly if you have a stateful machine like NSO. There's a little bit of problem because remember I told you there's two APIs. So now you have one configuration object and 2 representations. So it could, in the case of the MTU, it could be the case that you have 2 representations for the same data model, for the same configuration object. So which of the 2 is the correct one? So if we talk about NSO in particular, we will see that there's a lot of synchronization problem now across APIs. You program in one, the other one is out of sync. Now we need to work on, and actually the team has been working on. Okay? So, mixed model also, I think it's something to avoid if you can. Also because what we found out is that the vendor has not tested mixed models. So config may work, but delete may not work because when you delete, and you're deleting across different APIs, there's dependencies that may not work. Okay? Now, as I said, NSO is here to help you. And in the case of NSO, we got 3 different ways to deliver NetConf, RESTCONF, and gNMI nets. The first one is what we call the net builder. It has been our historical way to do NetConf APIs. And we saw in the case of Orange that they mentioned, if you got a very well-behaved NetConf device, it will work. It's included. It basically is self-service. But I call it sometimes the police of NetConf, correct? Because you have to be very well-behaved. One of those well-behaved devices is iOS XR. So if you're running iOS XR, you can have a licensed version, NetConf version for iOS XR. It's kind of like a special thing for Cisco iOS XR. So you can have a iOS XR 7.11 net, where we're going to be putting all the native young models of iOS XR for that version available for you to download from Cisco, which is going to be the same NetConf young models and net that the XR team is using for testing. Now, the third option is, again, something that was mentioned today during the Orange call, the presentation, and it has to do with the idea of these generic or special nets, correct? So these are still licensed nets. They are for NetConf, RESTCONF, and gNMI, and we issue them for specific vendors. So you can have a Nokia, as we were discussed today. We have Arista, we have Juniper, and what we do is we include in the net code to deal with the deviation, the special thing the vendor does that may not be, it may not be 100% aligned with the standard, or may not be aligned with our interpretation of the standard. That can happen. Documents are not. There's always a different way that you can read the documents. Now, I like in the previous presentation, they call it template net. And I like the word template net. It's very clever to call it like that because it's a special thing. Why? Because the net is separate, let's say, in 2 layers. One layer is the wiring, the core things of the net. Okay, that doesn't change if you change hardware from 7750, 7950, 7250s. That doesn't change. That's about how we create the How do we create the JSON object? How do we connect? All of that doesn't change. Even how we calculate the transaction ID to check the synchronization of the device. But there's the other part that is the payload. That depends on the young models. And that, yes, changed by vendors, but also changed by models. So the idea is a template net because we ship it without young models. And you fill the young models, and you compile the net for every version, deviation. You can choose which young model you're going to use. So if your use case, it's only to program the MTU, you may have a net with only one young model. And by the way, I recommend you to do that, particularly if you have a CI/CD pipeline, so all the synchronization problems are going to be much simpler to be solved. Okay? So extremely, extremely flexible. We got a lot of tooling to help you creating this net, putting net versions, etc. Okay, so it's like one net to reign it all. Now, we've done this for a number of vendors across gNMI, NetConf, and RESTCONF. All of this is available, and you can contact your representative to get them. Again, as I said, these are, they're called generic net. Or I call it generic because in NSO it will be configured as a generic net, but the official name is third-party NetConf, RESTCONF, and gNMI net. But one important thing is that they are available, and you see the number of use cases, and they can grow over time. I think that's also what we're discussing today. Now, I have a demo that I won't have time to do it in the computer, but I just wanted to show you, what is interesting here is that, again, a single declarative intent. I have a NSO service using FastMap, 2 nets for the same for my OS XR. One is a generic NetConf net, the other one is a generic gNMI net, but both of them with the same young model. Okay? So what happens at the end is that I can write an NSO service that has a single template, a single OpenConfig template, and in a single commit, I can commit NetConf and gNMI with the same template. The service code doesn't change. Okay? Moreover, if I want to do a net migration between gNMI, let's say I'm running a device in NetConf and the vendor end of life, or let's say gNMI, and the vendor NSO supports gNMI, and I need to move it to NetConf, I can do a net migration. And because they're the same young models, not only the migration is pretty much very fast, but also I keep the service metadata, the back pointers and the ref counts. No need to change the packages, no need to redeploy, reconciliate, anything to change the back pointer. So extremely useful. So that's why I said, you de-risk the choice. You may have done a choice, tomorrow you want to change, it's much faster to do it. So all in all, I'm running out of time, but I have a demo, so reach out to me if you want to see it. I may record it and put it online. So we are moving away from CLI. That's the right thing. We have choices. We had options. You have some homework to do if you want. Most of our customers, particularly, as I said, in more not trivial operational environments, they are going a lot with NetConf, with native models, just like Orange did. But if it is possible, if your use cases are simpler, to go, for example, with OpenConfig, and NSO, CNC are here to help you. There's a lot of toolings. Talk to us, and thank you. All right.
Thank you, Roque. We do have, I bought us a couple of extra minutes so we can take some questions from the audience.
I was really good with timing.
I know. Yeah, you were excellent. Extra points for that. So let's shoot some questions up on Slido. As a non-hyperscaler, do we need to use what they use since we don't have the same issues as them? We can easily stick to the standard methods and it works fine, basically.
That's a great statement. That's what I say. Do your homework, and what they're using a specific operational environment, and that's why I said confirm commit. If they were adding now, it means that they were not using it. That's because they didn't need it because they have a very standardized deployment, etc. So not every tool is useful for everybody, correct?
Yep. And there's one more. let's have a look. About OpenConfig, don't you think that it's quite challenging to have to translate the CLI to OpenConfig? Is it worth, especially when you use NSO, is it worth the effort to try to?
All right, yeah, okay. This is different. So when I introduced the gNMI to NetConf migration, I say you keep the same YANG model. All right? I didn't cover the CLI to NetConf migration. There was another session of it. And yes, it is challenging. But again, there's tooling for that. So you would need tooling. Typically, there's no better translator than the device. Correct? So typically what you would need to do is to program the device. I can program the device with CLI and if I have an OpenConfig net in NSO, I do a compare config and you got your template. So with NSO, it's extremely simple. You go to the device, go to the CLI, you do your configuration and you do a compare config and your template's automatically done.
Right, very good. I think that was the last question, actually. So thank you very much, Roque.
Thank you. And if somebody wants to see the demo, it's available.
Yeah, look up Roque for the demo later on. He has it here and maybe online later on.